Good day. Today, we will present our midterm project. I am Alberto M. in the third, and I will introduce my group mates and the part they will present. Hain Alberto the third, or myself, for the introduction. Pitogo Richard for the program features. Nazareno John Alexander and Lobedica Romar for the UML diagram. Reyes Justin and Rosaria Gelvi for the explanation of code. And lastly, we have Omictin Ayahel and Rica Franca Generos for the demonstration of the program. In this project, we are tasked to create a program that has three classes, the student class, the subject class, and the main class. We need to consider a student having an ID integer, first name string, last name string, and lastly, the course string. And for the another class, we have subject class, ID integer, subject name string, and lastly, units integer. We also need to implement class association to show relationship between two classes and identify the multiplicities needed considering the real-world scenario. In this project, there are things that we should keep in mind. First, a single student can enlist multiple subjects from the list of available subjects. Second, same students can enroll the same subject. Third, there can be more than one record of a student. Fourth, there can be more than one available subject for enlistment. Fifth, no duplicate subject can be enrolled in a single student. And lastly, all students can remove a selected enlisted subject. And for the program features, we have Mr. Pitogo Richard.
Hi, good day. My name is Romar C. Labedica, and I will discuss all about our UML class diagram for the student class. First off, what is UML or Unified Modeling Language class diagram? A class diagram in the Unified Modeling Language is a type of structure diagram that describes the structure of a system by showing the system's classes, their attributes, operations, or methods, and the relationships among objects. A class diagram is a box that has three compartments, namely the class name, attributes or fields, and the last is the operations or methods. The class name should always start with a capital letter and should always be in the center of the first compartment. The attributes or fields are shown in the second partition or compartment. The attribute field type is shown after the colon. The attributes or fields map onto the map member variables, data members, and code. Access modifiers can be represented using minus symbol for private and plus symbol for public, and pound symbol for protected to describe the accessibility of an attribute of a class. The operations or methods are shown in the third compartment. The return type of a method is shown after the colon at the end of the method signature. The return type of method parameters is shown after the colon following the parameter name, and operations map onto the class, methods, and code. In our UML, for the student class diagram, the class name is student. The attributes or fields are private ID num integer, private first name string, private last name string, private course string, and private subject. And for our operations or methods, we have public add subject void and public remove subject void.
Good day everyone. I am John Alexander Nazareno, and here is the next UML class. Subject class has private ID integer, private subject name string, private unit integer. For operations or methods, in addition, operations or method is an operation map into class methods in code. For our operations, we have public add to subject list, subject, void, public get class list, subject, void. The void represent as the return type in each end of the operations. The void is has no return type. It will display. And get class list subject void. Public get subject details void. Public get subject ID void. Public get subject name string. Public get units integer. Public remove from the subject list integer void. Public set subject ID integer void. Public set subject name string void. Public set subject unit integer void. And public view subject list void. It will display the subject list. For the multiplicity of class relationship, one dot dot asterisk indicates that the one or more entity type instances exist at the association end.
And now to discuss the main program by yours truly, Justin Reyes. First, let's see what are the requirements of the main.java file. The main program uh, is a menu-driven program that has 8 choices, including the exit. The first requirement is that we create a new student record. The second requirement is we create a new subject record. The third requirement is that we can enlist a subject to a student. And fourth is remove a subject from a student. Five is we display details of a student. Six is display all details of all students. Seven is we display all student details enlisted in a selected subject. And number eight, we exit the program. In order to accomplish that, this is what we did with our program. First, we've imported array list and list together with scanner as the scanner class, so that first we can store a master list of some sort for these student master list. And we imported scanner so that we can get user inputs. For the first part of the code, we just initialize a scanner object, namely sc underscore line and sc underscore integer is as a new scanner object. Then we create a list of students named master list that will store the students in order for us to create a menu driven program that continuously lets the user input multiple new student record, new subject. We have to do a while loop in the menu so that this while loop enables the continuous input of data. So first, this is just a printout to the user about the choices that is available to him or her. So first, just like I stated earlier, we can in number one we create a new student record. Two, create a new subject record. Three, enlist a subject. Four, remove a subject. 5, display details of a student. 6, display all details of all students. 7, display class list of a subject. And 8 is exit. Then we prompt the user to make a choice. This is where we will use the scanner object, and the input of the user will be stored in an integer. The integer will be stored in the in choice using the sc underscore int object of the scanner class. And that choice will be used in the switch statements um, for the menu. So for case one, which will create a new student record, we first get the info from the user. We ask for the ID number and we store it to ID num input. We ask for the first name and we store it in the first name input, surname to the surname input, and course to the course input. And then this piece of code validates the ID number if the number exists within the master list. First, we initialize an integer named index position to -1, as 0 would be a valid index position in the master list. So we create a for loop to iterate through the elements of the master lists, and every time we iterate through it, we check if the master list that get ID number is equal to the ID number inputted by the user. If this statement returns true, the index position would be overwritten by the index number of that existing ID number. And we will use this index position here in the next statement. Again, we check if the index position equals to -1. This means that if this returns true, the index position has not been modified by the if statement above. That means that the student ID doesn't exist yet in the master list. We can then now add that student as a new object of the student named new student, initialized to the constructor of student that has parameters. And those parameters are equal to the user inputs stored earlier with the ID num input, first name input, surname input, and the course input. After creating that object of the student class, we then add the new student to the master list using the .add method of the list class or the array list class. Then this piece of code allows the program to iterate through the master list as a confirmation or validation of the process that the student has been added to the master list. Else, meaning the index position has been changed, we print out a prompt to the user that the student ID is already taken. Now, for the case number 2, this is very similar in structure with the create a new student record. We just change the list to the list of subjects. Now, we first get inputs from the user of the course name stored in course name input, course code stored in the course code input, course units stored in units input. Then, once again, we use this type of validation. Index position is equals to -1, and we iterate for in the list of subjects um, present in the subject class. This list of subjects is a static list within the subject class, so that the list of subjects only exists in the subject class and not the subject objects. And this if statement checks if the subject that list of subjects and we get that index, meaning we get a subject and we get the subject ID of that subject equal to the course code input, we will overwrite the index position to that index with the same subject ID. Then once again, we use the index position to check if the subject ID is already in the list. If this statement returns true, meaning the index position was not modified, we create a subject object named new subject with the parameterized constructor and inputs from the user, namely course code input, course name input, and units input, and we add that to the new subject that add to subject list method using the add to subject list method, which adds this particular subject, this new subject, to the list of subjects existing in the subject class. Then, as a validation and confirmation of the process, new subject that view subject list. This is just a confirmation and validation if the subject has been added to the list of subjects. Else, meaning that the index position was modified, which signifies that the course code input by the user already exists in the list of subjects. Then the program will notify the user that the course code is already taken. For the tree, this is a very crucial part of the program. This case tree will enlist a subject to a student and adds the student of the class list of that subject. So first we are going to get the student ID of the student using the same method we used as a validation earlier, as you can see here. This validation is required because a subject cannot be enlisted to a non-existent student. If the student position was not modified, meaning that the student ID was not found in the master list, the program will prompt the user that the student was not found. Else, we proceed to enlisting the subject to the student and adding the student to the class list using add subject method of student class. So first we create subject object named subject 1, new subject 1. Then we use that subject 1 just to display the subject records as reference for the user because we will get the course code to be enlisted. Once the user inputs a course code, that course code will be validated through the list of subjects using, once again, that same validation method we are using earlier. We iterate through the list of subjects, and if that subject does not exist in the list of subjects, we prompt the user that the course was not found. We will now proceed to transfer the element of the list of subjects to a subject object named found subject. And then we create a student object named found student, meaning that the student validated here was found student equal to the master list that gets student position that we have validated here in the student validation part of the code. And then we simply use the add subject method of the student class to add the found subject object we've created here. And we get the full details of that student, confirmation and validation of the process. For case 4, we have a remove a subject from a student. Once again, we ask the user for a student ID because we cannot remove a subject from a non-existent student. So that way, we use the same uh, validation method that we've used earlier. We just iterate through the master list and we compare if that student ID is equal to any student ID present in the master list. If so, the student position will be overwritten by the index. Then we check if that student position was not modified, meaning it's still -1, just like here. It means that a student was not found. Again, we cannot remove a subject from a non-existent student. So, but if the student position has been modified other than -1, we proceed to display the subject list. How? We will be using an object of the subject class named subject1 and use the view subject list method present in the subject class to display the subject records as the reference for the user, as we will be using the course code uh, input as a uh, as the main course code input of the course to be removed. Once again, we use the same validation method. For here, with subject position, for iterating the list of subjects. If the list of subjects or has the course code input or equal to the course code input, then the subject position will be overwritten by the index of that course code, of that same course code. But if the subject position was not modified, meaning that the course was not found in the list of subjects, we prompt the user that the course was not found. Else, meaning that the subject position has been modified, we get the student object using this master list that gets student position, and we use the remove subject method of the student class, which accepts a subject. So subject that list of subjects that get subject position is the subject that we have determined to be deleted in the list of subjects. Then subject that enlisted students. The enlisted student is a static list of the subject class that stores the enlisted students for every subject object. So using this list, we use the remove method of the list and or array list, and we remove that student from the enlisted student list of the subject class. Then, as a validation and confirmation of the process, we get the full details of the student with whom we've deleted a with whom we've removed a subject. For case 5, we display details of a student. Will be easy. The only requirement here is a valid student ID. How do we get that? First, we let the user input a student ID with the same structure of validation that we've used earlier in the code. This part of the code, we use this to iterate through the master list and check if the ID number exists within the master list. If the student ID exists within the master list, we then modify student position to the index number of the student. Again, this is just a simple statement that checks if the student position has been modified. If it's not been modified, then the student doesn't exist within the master list. Else, meaning this student position now holds the index of the student. We use that to get the student here master list that get student position, meaning this is an object of the student, and we use the get student details method of the subject object, which display the details of the selected student. Now for the case 6, this is very short because it displays the full details of all the elements of the master list and its sub-elements, meaning we get full student details of all students will be displayed. Here we just use a enhanced for loop in traversing through the in displaying the contents of the master list, and this line of code just allows the program or the code to have a number before iterating through the master list, meaning if there are 3 students, we will see the count of the students. Then, using the student object of the master list, we just use the get full details method of the student class. For case 7, we display the class list generated in the subject class. First, we create a subject object named class members, and we use that class members to display the subject records as reference to the user using the view subject list method of the subject class. Then we ask the user to type in the course code to be enlisted. Then we validate that course code within the list of subject objects using the same validation method we've used in earlier in this program. If that subject ID uh, exists within the list of subjects with this if state using this if statement, the subject position will be equal to the index of that subject ID. Then we check if the subject position is equal to 1, meaning it wasn't modified. We notify the user that the course was not found. Else, meaning that the subject position was modified and that subject ID was found, we create a subject object named found subject, and we point that found subject to the subject at the index determined by subject position using this line of code. Then, again, using the class members being the subject object, we use the get class list method of the subject class, which uses the found subject object to print out the class list of that subject. Next up, we will see the program in action with our demonstrations of the program.
So, good day everyone. I am Jelby Rosario and I'm here to discuss the program code for student class and subject class of our midterm project. So first, we import the Java util array list and Java util list to create list of found object. And in the problem, it's said to consider that the int num as int, first name as string, last name as string, and cross as string. So here's our class fields, declaring it. So for the code for storing the subject list of each student is a static list subject student subject list equals to new array list subject that will allows a single subject list for per student object. For constructors, we define a default constructor public student and a parameterized constructor public student having the ID name as int, first name as string, last name as string, and of course as string. For getters, we define get ID num and get student details to display the student details and a get full details for the full details of the student. So this is working by a for loop by a for loop to traverse the subject list of the student and subject that gets subject details located in the subject class to allow the private class to be printed out. In a getters for subject, get subject, return the subject. As for methods, we implement add subject that will check the subject list of the student if it is empty using the size method or array list. And if else statement to do the things needed. In the if, the student subject list that size, which is pertaining to the size of the list collection, is equals to 0. So it is like this is where comparing happens in the student subject list that adds subject. First, the method adds the subject to the list of the student, and the subject and list student that add this. This is the syntax or the keyword that used to add the subject. In else, so it is also implemented by a for loop to check for the existence of the duplicate subject. And an if else after that, student subject list that get index that get subject ID is comparing to subject that get subject ID. If it is true, then system that outprint error duplicate subject for the display, and otherwise it will be student subject list that add subject, or the adding by this keyword is will implement it. For method remove subject is where we define the index position equals to 1 because the value is equals to 1 and not 0, since 0 is the valid index of a position. A for loop to iterate through the elements of the subject list of the student collection. So it means iterate. So it is like when you are searching for elements on item collection. So this is the code index 1 is equals to 1 index 1 student subject list that size of the item collection, and then iterate index 1 plus plus, then break, then another if for the comparing of index position, if it is equals to 1, if it's true, then the student not found, and else the removing of the subject occurs. In student subject list, it removes the subject using the index position value recorded earlier, and then the subject enlisted student that remove this. So here again is the this keyword remove the student from the class list of the student of the subject. So we go on subject class. It is more likely of the student class, more the same. First, again the import Java util array list and the Java util list. In a class field of subject ID as in subject name as string, unit as integer, and we also add in the class field the this static list student enlisted name enlisted students equals to new array list students. Students that have been enlisted is stored per subject object in here in this code. Then another one is the static list subject name list of the subjects equals to new array list subject. So this is where list holds the subject records created by the user. So again, the constructor as a default and the parameterized constructors having the subject ID, the subject name, and the units. For getters, get subject ID. We have the get subject ID getters, get subject name, get units, and so on. And again, the for displaying the subject details, the getters for it is the get subject details. Setters, we set we set the subject ID as the set subject ID, and subject name at the set subject name, and units at the set subject units. Methods. Public void add subject list subject allows the main program to transfer the subject object to the list of the subjects. So list of subjects subject that adds subjects. Subject is the keyword or syntax. And for the remove from subject list, enlisted subject that remove index. Another one is the method of view subject list that iterate through the list of subject for displaying. For displaying. So in position is equal to 1, then another for loop subject list subject, and then printing this position printing the position plus plus the iteration and the and get subject details or the getters for the displaying the list of the subject. Get class list subject is another method to iterate through the list of enlisted students in order to display the class list per course or subject. First, we printed the class list and then integer position is equal to 1, then another for loop for the iteration or searching that in index is equals to 1, then if the index is less than enlisted student that size, then index plus plus. If this work system that outprint position plus plus, then the enlisted student that get index, then printed by again by the get student details. So that's all. Thank you.
Good morning. I'm Ayal Umitin and I'm going to demonstrate what will happen if we input an information in this memory event program. So we have a student Java file and a subject Java file and a main Java file. So as we run the program, this is the menu driven that will be displayed. We have 1 to 8 choices and I'm going to demonstrate 1 to 4 only. Then my classmate will be the one to continue to demonstrate 5 to 8 choices. So first, I'm going to choose choice number 1, which is no student record. As you can see, the program asks the user to input their ID number. So I'm going to input my the program asks the user to input their first name. I'm going to input my first name, which is I. And the program asks the user to input their surname. I'm going and the program also asks the user to input their course. So I'm going to input BSI. As you can see, in choice number 1, create new subject record, the program outputs full name, which is IL Umitin, ID number, which is 2030, and the course, which is BSIT. Next, let's choose number 2. Number 2, which is create new student subject record. So the program asks the user to input their course names. I'm going to input BSIT, input course code 108. The program asks the user to input its course unit. So I'm going, for example, I'm going to input 6. As you can see, the program outputs the course, which is BSIT, the code, which is 108, and the units, which is number 6. Then let's try choice number 3, which is enlist a subject. So I'm going to make a choice, which is number 3. Then the program asks the user to input their student ID. So I'm going to input my student ID. And then the program asks the user to type their course code to be unlisted. So I'm going to type 108. As you can see, the program outputs my full name or the student full name, which is IL Meeting, ID number, which is 2030, course, which is BSIT, and in subject, we have the code 108 and units number 6. So let's make another choice. Choice number 4, which is remove a subject. The program asks the user to input their student ID, so I'm going to input 2430. And the program asks the user the course code to be removed. So I'm going to input, for example, the course code that I inputted a while ago, which is 108. Let's see what will happen to the program, what will the program will output. Um, as you can see, the program outputs the course which is BSIT, the code which is 108, the unit which is 6. And when I inputted the course code to be removed, which is 108, you can see there is no subject displayed because I already removed the code of the course. That's all. Thank you.
Good morning. I am Generosi Capranca, and I'm the one who will demonstrate 5 to 8 because already demonstrate the 1 4. So choose number 5. Display details of a student. In, input the student ID number 1001-227. So it's already display the full name and ID and course of the student. Then number 6, display all details of all students. It's already displayed. The number 7, display class list of a subject. Then type your course code to be enlisted. The course code is 108. The class list are already displayed. The number 8, exit. Thank you and have a great day. That's all. Thank you.
Okay, good day everyone. My name is Richard Pipitogo and now I'm here to present the features of our code. Code can be categorized in terms of its easy to understand, efficiency, and related to the topic discussed. In our program, we use UML or Unified Modeling Language as guide to our program. So first is easy to understand. In terms of easy to understand and readability of our group, prioritize the naming convention of naming the variables related to its function or object. For example, in our program, if we're going to ask about the student info, then our class fields will be named correspondingly to their data like ID number, first name, last name, course, and subject. When it comes to readability, we make sure that we put comments on what is the purpose of the code. For example, about every code, there is comment telling what is does like comments or class fields, constructors, methods, getters, setters, and so on. So the next one is easy to understand. When it comes to efficiency, we make sure that the series of code are not redundant and can be used by each subclass. For example, we just call the method inside the student and subject class if we're going to need it. This process lessens the runtime and making it more efficient since the code is reusable. And lastly, the code should be related to the topic discussed by our professor, which are creating object and class constructors and class association. Our topic is class association. That's why the classes were created as student class subject, whereas the students can have or many subjects, and there are also many subjects available for the students, but can't duplicate if he or she already enrolled on a particular subject. And that's all for our code program. Thank you.